Hello, I am Joseph Marinello, and for my project, I'm going to be analyzing the Marvel Cinematic Universe. Marvel has recently achieved some outstanding performance in the movie industry. Just recently, their latest Avengers movie, Avengers Endgame, was the highest grossing movie of all time, surpassing Avatar. So, the goal of this project is to analyze the social and commercial presence that they currently have. The techniques that I'm going to be using for this project are text mining, sentiment analysis, map visualization, predictive modeling, and Shiny app development. The first thing that I did was some text mining. So, using the rtweets package, or rtweet package, I searched 10,000 tweets containing the hashtag Marvel. By doing this, I was able to have 7,086 observations. Another thing I made sure was to focus my search around the United States. So, individual tweet information was taken and manipulated for analysis. The first thing I did was to convert all the text to lowercase, and then we removed some punctuation, removed all numbers from the tweets, and removed any English stop words. With the data now cleaned, we can look at some frequency of words that were used. Out of all of the tweets, the top 5 words were SDCC for San Diego Comic-Con, Avengers, MCU for Marvel Cinematic Universe, Spider-Man, and comics. Just looking at some of the superhero character names, the top 5 used in the tweets were Spider-Man, Thor, X-Men, Blade, and Iron Man. The next thing that I wanted to do with the text mining was to generate a word cloud for all of the words. As we can see here, there's a word cloud that was generated with all of the words in the tweets. Here we are looking at the top 75 words, all containing at least 135 frequency. In the red are the most prominent words, being Avengers, Spider-Man, MCU, and SDCC, followed by the purple of comics. The green are the third most common, and here we can see the word Thor and Disney, X-Men, Comic-Con, Marvel Comics, and Marvel Studios. Blue marks the fourth common words, and here we see more Marvel-related terms, but also we see Endgame, Captain Marvel, Iron Man, Blade. In the black, we see the fifth most common, and again, they contain stuff like characters like Deadpool or Black Widow. Altogether, this really doesn't give us much information about the tweets themselves. Wanting to get a little bit more specific and to try to get a little bit more information out of these tweets, I looked at only the words containing a character's name. With this, we can kind of get a sense of who's popular right now in the current atmosphere of Marvel Comics. Again, we see Spider-Man in red as the most popular. This can be due to the movie of him that just released this last month. We also see Thor as the next most common, and that could be due to some of the new announcements that were made at the San Diego Comic-Con. In green, we have the third most common out of X-Men, which is interesting, because they don't have an actual movie yet in the Marvel Universe. So there could be some excitement, or maybe even some negativity towards those characters. The blue marks the next most common, and there we can see a lot of characters that we're familiar with and some that are new that were announced at the Comic-Con. And then in black, again, we see characters that we're familiar with and some new. Altogether, this really can only show us some of the interests that people have, but not necessarily anything beyond that. Moving on to the sentiment analysis, we try to gain some insight on those word clouds. So, searching the tweets for positive and negative words, actually, we found some poor performance from this technique. Many character names that are inside of the Marvel Universe actually mimic both positive and negative sentiment. The word Marvel, as in Marvel Comics, and also the character, Captain Marvel, is seen throughout and is considered to be positive. This artificially inflates the amount of positivity that we find in the tweets. On the other side, Strange, Villains, and Fiction are all considered negative, but in the context of the tweets in the Marvel Universe, actually are not negative. Therefore, with sentiment analysis, more time would need to be allocated towards the sentiment analysis to get any sort of useful idea. When looking at the percentage of positive words to total words, I saw about a 4% positivity rate. Contrasting that to negative, there was about a 2% negativity rate. Now, we can't really use these because, as I mentioned before, the positive and negative sentiment were contaminated by words like Marvel, Strange, Villains, and Fiction. Moving on from the text mining, we're going to look at map visualization. One thing I wanted to try to do is take the location data from the tweet observations and get a sense of what region of the United States is most active in the Marvel conversation. So, using geocode to find the latitude and the longitudinal coordinates of each tweet, and using getMap and ggmap to visualize the coordinates in a plot, I was able to get a map of the US with location data for every tweet. Now, not every tweet was made the same. Unfortunately, some users use custom or fake locations on their tweet. A lot of the time, these were just jokey locations, something like Home Sweet Home, that does not have any real location or way to verify. However, most users had location data that was just default to their state or their city. Therefore, I was able to continue with the map visualization, with only about 1,000 or so observations lost due to the fake custom locations. Here we see the states and red dots to indicate every tweet that was observed. We can see that there's a lot of activity in 3 or 4 areas on the map: California, Texas, Florida, the New England area, and somewhere in between the Northeast, the Midwest, and the South. Because there were so many observations, I felt it necessary to use a density map to kind of get a sense of just how many tweets there were in a given location. Especially in the Northeast, we can see it's very tightly packed. So the density map actually shows us that the Northeast was the most active area, followed by California, and then the sort of area that's in the middle of the South. So, looking back on the tweet analysis, overall, not much can actually be learned from the tweet data that I collected. In spite of some insight on some trending characters like Spider-Man and Thor and X-Men, there's not really much we can go off of there. Sure, we can kind of gauge interest or current popularity on some characters, but there's not really much to go on with that sort of data. And also, the locations of interest is cool to look at, but there's not much to go on based just on the locations of the tweet. Also, combining that with the poor sentiment analysis, where the positive and negative connotation was hard to distinguish, I feel like the text mining and the tweet analysis just didn't quite do what we always wanted to do, and that's be insightful. So, to counterbalance the poor tweet analysis, we're going to do a little bit of predictive modeling and Shiny app development on a secondary dataset still related to Marvel. So, as we mentioned in the beginning, the Marvel Cinematic Universe has been absolutely destroying the movie industry. Marvel movies are big moneymakers in the business today. So, we're going to attempt to build a predictive model for potential earnings of a new movie based on data of all the previous Marvel films. I also want to try to keep this to be as realistic as possible. So we're going to try to build a realistic model, only being able to predict the potential earnings based on the production budget. So, a little bit about the dataset I'm using. The dataset contains every MCU film, and the data includes the production budget, the opening earnings, the domestic earnings or domestic box office, the foreign earnings or foreign box office, the total earnings, which are the domestic earnings plus the foreign earnings minus the production budget, and the profitability, which is just the total earnings divided by the production budget. So, for the predictive model, first we split the data into a train and a test set. Then we build a linear model predicting the opening earnings with the only predictive factor being production budget. Then we apply the model to the test data, calculate the error and RMSE value, and then we plot the results to visualize the error. Here we see the plot of our linear model error. If we look at the legend, we can see that the size of the dot indicates the magnitude of the error, as well as the color of the dot. And also on this graph, we have a line that helps to visualize the size of the dot. So the x-axis, we can see the production budget, and that's 150 million is the leftmost, and 300 million is the rightmost. And then on the y-axis, we have our predicted opening earnings. So as we can see, the movies in the test dataset that we try to predict the opening earnings, the ones with smaller production budgets, we actually got very, very close with little error. We're talking about, let's say, a movie that has a production budget around $150 million, making roughly $100 million on the opening weekend, and our prediction was able to get less than 25 million in deviance. It's not until we get to the larger production budgets where our model started to have a little bit of an outlier. Although not the most accurate model across the board, I do feel okay with this model, and especially given the scope of this course. I just wanted to have a little bit extra of analysis on this data and seeing what possibilities could come out of it. Moving on from the predictive model, we're going to look at a Shiny application I made for this movie dataset. So, to gain a little bit more insight than what the predictive model allowed, we're going to fully explore the movie dataset. With a simple scatter plot and a wide variety of user-changeable variables, we're going to gain insight on the data in a more intimate way. Here we have the Shiny application with the Marvel Cinematic Universe movie dataset applied. We have an x-axis that can change with a bunch of variables, a y-axis that can do the same, a size parameter, the fill, which correlates to the color of the dots, and a simple variable to change the outline of every dot. So, by using this application, you can test a wide variety of different graphs to gain insight on the dataset. So, to start, on default, we have the title of the movies on the x-axis, the domestic box office earnings on the y-axis, the size of the dot is also the opening earnings of the movie, and the color, the fill, is the foreign box office earnings. So we can see that a movie that is higher on this chart made more in the United States. A movie with a larger dot made more on their opening weekend, and a movie that is brighter blue made more in the foreign markets. The best thing about this app is the ability to just play around with the variables. So let's say I wanted to look at the production budget on the x-axis, how much total earnings on the y, and let's say that the size was the domestic box office, the fill was the foreign box office. So we can see a movie on the right hand side of the x-axis has a higher production budget, meaning it costs more to make. However, a movie that's higher up on the list on the y-axis actually earned a lot more money. And then we can see the size of the dot correlates to how much money it made in the US, and the color, how much money it made overseas. So we can see here that this movie, although it didn't make much money, although it didn't cost much money to make, it really didn't make much money, and it didn't make much money overseas, and it really didn't make much money in the US either. However, a movie like this, even though it cost a lot of money to make, it earned vastly more than any other movie, and you can see it correlates with the US and the foreign. Now, one thing to look at, even though we have a movie like this, which looks like it really didn't do that well, and a movie like this, which looks like it did amazing, this data can kind of be a little bit misleading. So, one thing I wanted to look at is the profitability of a movie. So, I'm actually going to move that back to production budget, and then we're going to change the size based on profitability. So now we have the same sort of chart. However, the larger the size of the dot, the more profitable it was, and the smaller the dot, the less profitable it was. And so we can actually see that the data wasn't that misleading. This movie down here relatively stays the same, and it had low profitability, meaning the money that it made back was close to the money that it cost to make. The best part about this app is just how fun it is to play around with the different variables. So let's say I want to look at profitability, and let's see the title of a film. Actually, how about we switch those axes? So we say the profitability. So we can see which movies were the most profitable. And let's say we can change the color to be production budget. So the movies that cost more to make are in a lighter blue, and the movies that really didn't cost that much are darker. And let's change the size. So let's say the size to be, let's see, we have profitability, we have title. Let's say the opening earnings. So the larger the size, the more it made in its opening weekend, and the smaller, the less it made in its opening weekend. So we can see a movie like Avengers Endgame, which we know is the highest grossing film of all time, made a lot of money in its opening weekend, and its production budget was the highest anything here. However, it wasn't the most profitable movie that Marvel has made. That actually goes to this one here, Black Panther. And we can see that Black Panther really, on the production budget, if we look, it's relatively dark, so it didn't cost too much to make. However, its size is pretty sizable. I'd say it's probably medium. And it was the most profitable movie that they had. So that's just a really cool way, using the Shiny application, we can see a bunch of different variables being used to gain new insight on the dataset. Another interesting thing that I'd like to look at is, let's see, we'll look at the domestic box office, and then we'll look also at the domestic box office. So we'll get a nice linear line here. And then I want to look at, we'll see how the size changes based on certain things. So we'll look at profitability here. And then we'll also look at, let's say the fill, we'll say total earnings. So the brighter the blue, the more it earned overall, and the bigger the size, the more profitable it was to make. And then we can just see that it's domestic and it's domestic. So we can really see that overall the sizes are pretty similar. There's a few that are relatively small here. There's these small ones, but roughly they're roughly all the same profitability, which is interesting to see. So how much it costs to make the film versus how much it's pulling in is pretty similar across the board here. Now let's see what happens if we do the foreign market. So if you look at the foreign market, we can see there's more variance in the size of the dots. Actually down here they seem to be very similar, but there's a lot more variance in the mid-range, and then going up to the outliers here. So we can see that there's a difference in the foreign market and the domestic market just by doing a graph like this. Alright, so because I like to play around with this so much, we're just going to see if we can come up with any more interesting things to look at with this. So let's see, or no, let's flip that. So let's say the title, and we can also say the release date. Let's see if there's anything we can gain from looking at the release date of a film. So if we look at the title of the film, actually let's not look at the title of the film. Let's look at the domestic box office. Actually no, let's actually look at the opening weekend, opening earnings. So opening earnings versus the release date. So we can try to see if there is a month in here that there's a big spike in opening earnings. So if a movie is on the right hand side, it means it made a lot in its opening week or opening weekend, and if it's on the left, it really didn't do that well. So we can see a lot of movies here are grouped together, and they seem to take place throughout the year. There's nothing really special. And then we have this sort of mid-range group. Yeah, they're kind of, it does tend to seem like there's maybe a bit of a trend towards this sort of, what is that, January, February, March, April, sort of like this April release date. We see a lot of, there's a 3.8, a 4.26, a 4.27, a 4.4. Yeah, I'm not too sure if we can really call this a trend, however. Let's see if we can find out what's going on here. So let's look at, I like looking at profitability. How about looking at, let's say the fill is the production budget. So let's see if we can, let's see. So these two films cost the most to make. Let's see, that was Endgame and that was another Avengers. So the two Avengers movies cost the most to make. And let's see, so the production budget, the profitability is the size. So the larger it is, the more money it actually made, the more profitable it was. We can see that these ones are pretty profitable, and these ones, I don't know, it's too hard to see. Maybe I've found all the interesting data through playing with it already, but yeah, the Shiny application definitely does wonders at into looking at the data and seeing what cool things you can find.